All right, AP, this is sample exercise 4.050. We're predicting reaction products. So using the solubility rules in table 4.1, predict what will happen when the following pairs of solutions are mixed. So you're going to do 3 different problems, 3 different versions of this question. Go ahead and press pause now, because here comes the solution. So the formula, potassium nitrate KNO3 aqueous, represents an aqueous solution obtained by dissolving solid KNO3 in water to form a solution containing the hydrated ions. Hydrated means surrounded by water. It's been completely dissolved. K plus and nitrate minus. Likewise, the BaCl2, that's a barium chloride, represents a solution formed by dissolving solid barium chloride in water to produce barium plus 2 ions and chloride minus 1 ions. When these two solutions are mixed, the resulting solution contains the ions K plus 1, NO3 minus 1, Ba plus 2, and Cl minus. All ions are hydrated, but the aqueous, the state is omitted for just simplicity. To look for possible solid products, combine the cation from one reactant with the anion from the other. So potassium was with nitrate. Let's see what happens with it if it gets together with chloride. Barium was with chloride, but let's see what happens if it gets together with nitrate. Note from table 4.1 that the rules predict that both KCl and barium nitrate are soluble in water. Therefore, no precipitate forms when KNO3 and BaCl2 are mixed. All the ions remain dissolved in solution. No chemical reaction occurs. Go on to the second one. Using the same procedures as in part A, we find that the ions present in the combined solution before any reaction occurs is Na+, SO4 2-, Pb plus 2, and NO3-. The possible salts, meaning the ionic compounds that could form precipitates, we don't know if they will, it could be sodium nitrate, and it could be lead sulfate. The compound sodium nitrate is soluble according to the solubility rules in table 4.1, but lead sulfate is insoluble. When these solutions are mixed, lead sulfate will precipitate out of the solution, and so the balanced equation is going to be represented as such. Sodium sulfate plus lead nitrate reacts to form lead sulfate and sodium nitrate. Note, aqueous, aqueous, solid aqueous. This represents the fact that a chemical equation has taken place. And for C, the combined solution before any reaction occurs contains the ions K+, OH-, iron 3+, and nitrate minus. The salts that might precipitate are potassium nitrate and iron 3 hydroxide. Hydroxide. The solubility rules in table 4.1 indicate that both K+ and nitrate minus salts are soluble. However, iron 3 hydroxide is only slightly soluble, according to rule 5, and hence will precipitate. Now, it doesn't mean all of it's going to precipitate out. It's only slightly soluble, so that means some will dissolve, but there'll still be some in a solid form. So the balanced equation is represented as such: 3KOH aqueous plus iron nitrate aqueous reacts to form iron 3 hydroxide solid plus potassium nitrate. Again, aqueous, aqueous, solid, aqueous. That's the dead giveaway that a reaction has occurred in solution.